Messy Data Part 2, Even Messier Data. I'm going to review a little bit just so everyone's on the same page. One, what is OpenRefine? You'll recall it's a tool for working with and transforming data. It's compatible with a lot of formats. Last time we worked with a CSV. This time we'll be working with some URLs, looking at HTML and some JSON. And it can also reconcile and quickly standardize data and augment data from the web, which is what we're going to be doing today. It runs on a small Java-based server. You don't need the internet to use it, except for today you will, because we'll be accessing some stuff that's hosted on the web. There is a little terminal command line window that opens up sometimes. I'd like to remind you that you can absolutely ignore that. It seems a little scary maybe, but it goes away once you exit OpenRefine. So if you ignore it, it will ignore you. So what is web scraping? Just so we're all on the same page, it's basically just a lot of copying. It's copying other people's stuff, which I kind of like, as long as you credit people. So it's gathering content from the web, taking it, and then what our goal is to make it into something that's actually useful for us. So how does OpenRefine help with that? It has a lot of tools that can parse different formats, especially HTML and JSON. It can also work with XML, and a lot of the stuff I'm going to show for HTML works almost exactly the same for XML if that's something you work with more regularly. And it also allows users to process and create a lot of requests at once. The great thing about OpenRefine is how it scales up. So you'll see where that can be a utility today. Some things we are not going to be doing today is making a lot of calls on web pages that are from small or nonprofit organizations. Every time you access a web page, especially if you're using an API, it puts pressure and it takes resources from a website. So if you do a lot of that at once, which OpenRefine lets you do, it can kind of be a burden for a small web page. So keep that in mind. We're going to try to be polite. And then we're also not using like AI or an automated process to get data from the web. Even though we're automating portions of this, we're going to be doing a lot of the work ourselves. So keep that in mind. But we are going to be extracting data from websites, taking stuff that's not meant to be in a CSV form or isn't easy to be in like a spreadsheet type form, and transforming it into that to make it easier to use and search. So with that all out of the way, let's actually do the fun stuff. So I'm going to this Project Gutenberg language of flowers page. So throughout the session, I'm going to have two kind of windows open. So OpenRefine is going to be the big one, but I'll also be going over to here just to show you some stuff. So we have the language of flowers. As you can see, it has images, it has words, classic book stuff. And what we're going to be doing today is, as you can see, we have the flowers and then what they mean based on Kate Greenway's interpretation. We're going to be transforming this into a CSV that we can use and work with. Oh, I have OpenRefine up. Feel free to open it up as well. Click along with me or just watch. And the question is how to get this into here. The intuition may be to do web addresses, URLs, right? Because it has that and it can handle that usually. You can do a lot of URLs at once. But if we click next, you can see it's treating this like an XML file because that's how it processes web pages. And if we scroll down, it ends, this is where all the stuff we want is, but it's not accessing that just because of the way it parses this stuff. So another thing that may be kind of like the intuition is, and what I'm doing right now is right clicking and doing view page source, which is a fun little trick if you're ever wondering how a website is built, or if you ever need, you like how a website works and you want to see what their HTML code is, this is a great way to do that. So another thing you may be inclined to do is take all this and put it into the clipboard. But you run into the exact same problem because you're doing kind of the same thing. And the way it works with this stuff is it doesn't want to dive any deeper than this. So I will show you the completely non-intuitive way of actually working with the information housed in the HTML there. So what we're going to do is we're going to copy the URL into the clipboard. So again, not super intuitive, but I promise it works. We'll go to next. So it understands what we're doing. We have this measly little one column, one row, a little project here. You can create the project. We covered that in the last workshop, what goes into creating a project. So hopefully you trust me that I did it right. And we have our little our little guy here. How do we get this to something we want? Under column, you'll remember we have quite a few options here. So column, we're going to go to edit column. We're going to use this tool right here, add column by fetching URLs. And we don't need to mess with it too much. As you can see, we have a preview, and we'll be looking at this a lot today, this preview area. And for now, it looks like it's not going to be doing anything. I'm going to call this fetch because we are trying to make fetch happen in this workshop. We are going to click OK. We're just going to trust that OpenRefine knows what we want, and it does. So that's the best way that I've found to consistently get good HTML, is to have OpenRefine fetch the URL after you've already opened up and created the project. So we have over here all of the HTML, so the exact same stuff that we have here. So that's the easy part. Now we want to actually get information out of it. And I highly recommend anytime you're dealing with this this type of stuff, it's hard to read, but looking and getting a lay of the land can be really helpful. So seeing where stuff repeats, like we have, you know, the TRs with the flowers and their meanings, that seems to be a repeating pattern. Just keeping that in the back of your mind can be really helpful with this type of stuff, especially if you want to, you know, do something over and over again in a way that follows a pattern. So now let's actually extract stuff. And I pointed out that this is the stuff we want. We want the flower and the name. And you'll notice that all of that information is hidden within this TR class. That stands for table row. So all of these things are actually built in. These are all tables in HTML, and each row is a flower in the meaning. So we'll take note of that, and we'll go down. We're working with this HTML column. And this time we're adding a column based on this column. So this is where it gets fun. We're going to be doing some GREL, some general refined expression language. Super exciting, at least I think. You can also, I'd like to note, use Python/Json and Clojure if those languages are more comfortable for you. Obviously, the syntax will be different than what we're doing today, but there is compatibility with those languages. And I do use Python in OpenRefine. Not infrequently, but today we're going to be doing GREL. I'd like to note, just like with any programming language, you're not expected to memorize the syntax. You're not expected to know off the top of your head exactly how stuff goes together. It's just knowing what you're able to do, like saying, I know I can parse HTML with GREL, and being able to say GREL parse HTML in Google and finding the recipe for it. So I've practiced this, so I know all the expressions off the top of my head, but don't think that's usual. All right, so we have the expression box right here. And what's nice is that they show you a preview of what's going to be spit out. So you can't really make a mistake because it will tell you if you're going to make one. So let's see what happens. So GREL has an expression built in for parsing HTML. And I'd like to note that there is also a parse XML, but it's not going to work because this is HTML. But if you want to work with XML, it's going to be very, very similar. They work pretty much the same. It's just different letters. And I'd also like to note that this is case sensitive. So I always want to type this. It doesn't know what that is. So it is case sensitive, just as a warning. So this tells OpenRefine that we're working with HTML, and that's the structure, and that's what's going on. It gives it a little bit of a guide. And then an expression that you can add to this. And again, this is something that I know because I work with this and you can always look it up, but having these in your back pocket is really useful. So parse HTML has a function you can use called select, which allows you to select certain elements from the HTML you've got. So we've got select right here. And then in quotation marks, we have that TR. And this could be, you know, any of the HTML objects. TR just happens to be the one we want. So this select is really useful for extracting stuff out of HTML, especially if you have a lot of items you want and they all kind of share the same class label. So we've used this, and this looks like, you know, good. We have all the stuff we want, right? And we may be tempted to say, okay, this is fine. Let's make a thing. But if we do that, one, you have to enter a column name. We'll do table rows, just because that's what we're doing. You can barely see it over here, but it's blank. And we'll remove that for now. But the reason it's blank, and I'll show you, and this is where OpenRefine is so nice to you, but it's also so tricky. And I always forget these little brackets. And that's just the syntax of the language. Some stuff doesn't require that, and it's just about knowing, being able to look it up with what. If you see right here, we have a little square bracket there. And what that's telling us is that the result of this expression, what it's going to spit out, is something called an array. And you don't need to know too much about arrays, but they're really useful and they show up a lot, is that they're inside square brackets and they're lists of stuff and they're indexed. So that means you can start at one number and go to another and pull out really surgically and precisely different parts of an array by using the index. So a few little fun facts about indexes. They start at 0. So the first entry is the 0th entry. And you can move through them using these square brackets, right? So this is the 0th entry in the array that this chunk spits out. If you've ever worked with Python or any other languages or dictionaries or things like that, this may not be that foreign of a concept to you. And arrays work the same in OpenRefine as they work almost anywhere else. The thing is, we don't want just the 0th or the first or the second entry, right? We want all of it, but if we don't select all of it, it spits out a blank thing, right? This is where we're going to use something called slice. And you'll see I'm building stuff, right? So OpenRefine, this language grell is really buildable. You can just add stuff and add stuff and add stuff, which is pretty nice. So we're going to be using something called slice. And this is where you can put your start number and your stop number. And it's going to start at this one and end at that one. And the reason I know these numbers is because I came prepared and I counted before I started here. The 4th entry, you'll see, if we go back and go to entry number 4 using our little brackets, that's the very first of the flower meaning pair. And then the negative 731th is where the last table ends. And the negative means it's counting from the very, very end. So this is the 731st from the end, and this one is the 4th from the start. So they're a little tricky to get used to, just because, at least for me, it could be super easy for you. But for me, they're I have to get into an array state of mind to work with them. But once you're there, it starts adding up. And again, all this stuff you can look up, so no one expects you to remember. But that's what a slice is. It's taking the chunk that you're setting it for. However, you may notice, those of you who are looking at the preview, we still have this bracket, right? So it's still going to spit out an array, and it's still going to give us a blank column. This is my recipe, and by mine, I mean probably someone else's, because nothing's original. But this is a recipe for taking something like this, taking an array, and making sure that it spits out what we want, and we can also separate it later. And you'll see it again later in the presentation, but it's a join. So it's going to join all of the things that are in this array, and then we can tell it what to join it with. And if you remember from last workshop, this is kind of like putting cells together, the split multi-valued cells and the join multi-valued cells. It's very similar, and you'll see in a bit. But as you can see, no little bracket anymore. So we're no longer getting an array. And you may notice these little guys. That's what's separating all the different entries. And this can be anything, right? So you'll watch as I change what's in here, it's going to change what's in here. It can be anything you want. The reason I like the 3 pipes is, one, it's easy to type. It's easy to see for me. And also it very rarely appears in written text, right? So I don't have to worry if I chose like the letter A, that wouldn't be super useful because A shows up all over this text. So picking it carefully is kind of useful, and usually strange symbols more than once in a row is a pretty good bet. But now we have this, it looks good. So what we're doing is we're selecting all the things that are in the class TR, and then we're choosing only the 4th through negative 731st of them. And then we're joining all of those together into one cell using this separator. All right, we'll click OK. Oh, column name. I wanted to do that naming for me, but gotta do it myself. All right, there we go. And then you can see, we go over here, that's what we've got, just like the preview said. The second part of this little trick is separating them. So we have them all in one thing. Now we want them all separate. You may remember this from last time, but we're going to go to Edit Cells. And we're going to split multi-valued cells. As you can see here, we have the separator. This is my common one, so it automatically fills, but you can put anything here. You can also split using regular expressions if you have like a certain pattern of text, like a parentheses and then 3 spaces and then a capital letter, but the capital letter changes, you can do that too. So if that sounds like something, if you're looking into more complex splitting, regular expressions may be good for you. But for now, we're doing something really simple because I got to choose, so I chose something really simple. We're going to click OK. And then ta-da. So this is kind of, the nice part. We have this giant wall of text, and we're going to be using Facet to take kind of a bird's eye view, one of my favorite things to do. Now we have 773 rows, and they're all kind of nice little chunks of stuff that may or may not be interesting to us. So as you can see, some of the chunks are not the flowers and meaning pairs. This is one of the images, so that is its own little element, right? But you can also see that some of them are the ones we want. So that's good to know. We've already started breaking it up. And if you go all the way to the bottom, you will also notice that there are no blanks, which is pretty good. And everything is almost individual with the exception of that, which is just creating new tables of the same size. So there we go. But this is still like this isn't data we can put into a spreadsheet, right? It's broken up and it's less cluttered, but we can't actually get our hands on it. That's where looking at the HTML and picking out patterns is going to be really useful. So if we take a look at this, you can see we have the TRs. This is the table row, and it consists of this TD, which is table data. That's what it stands for, which is the flower, and then the meaning. And you'll see that the meaning is housed within these eyes. I always like to start with the easiest thing and hope that once I solve the easiest thing, it may make the other parts of the problem also easier. That doesn't always work, but sometimes it does. And this seems easier to me because it has this clear split. And that's because these are in italics, and that's what that I means. Which, if you're familiar with HTML, will come as no surprise. So if we can start by isolating that thing, maybe we can isolate the others a little easier. We're going to go to Edit Column, Add Column based on this column. And by the end of this, you guys will be old pros at that clicking cycle, because we're going to be doing that a lot. And we're also going to be doing value. And then parse HTML, once again, because we're still working with HTML. And you'll see when we do that, it adds all these little HTML extras, and it takes away these guys. So it converts this into something that's really, really simple HTML, which is sometimes useful, sometimes not. In this situation, it is, because this I is really understandable by HTML. And it's a thing we can use select on. Right, so there we go. So if we scroll down through the preview, you can see we've selected only the meanings, which is great, but savvy viewers will note it is still in an array. And we could use slice, right, like we did before, and just do 0 to 1, but that keeps it in an array, remember, because slice also returns an array. Since this is only one item, we can just use the easy peasy brackets to select that one item, right? So no longer in an array. If we want to get rid of these little eyes, because that's not a part of the thing we're interested in, we don't really care that it was italic, we can use another really useful expression, which is HTML text. And this is how you extract all the text from HTML. And it works, with any HTML. So if I were to, undo this little chunk, then it would take out this text as well, because I haven't narrowed it down. So anytime you have HTML and you just want to extract the text, this recipe will do it for you. But we only want one of the words. We'll give this flower meanings. Okay. And then we have nice little flower meanings on the side. And once again, we'll facet, get a bird's eye view. So we have 773 rows and only 598 choices. If we go to count, you'll see that there are some repeats. That explains why we have fewer choices. You'll also notice that we have 60 blanks. I always like to check out the blanks because sometimes they make sense and sometimes they don't. So checking out the blanks, it looks like it's just the images and then the things that are used to build the tables. And it makes sense that those are blank if we're trying to extract flower meanings, because these don't have flower meanings associated with them. But we will exit out of that. So, but it's always nice to do a little sanity check with your data. It can be really easy to just forge ahead. And sometimes taking a moment to make sure things are adding up can save you down the line. But there always is the undo redo. So if you get yourself into hot water, you can always go backwards. But all right, so we've got the easy part down. Let's see if we can do maybe the little bit of a harder part. So we'll start the same way we've been starting. Edit column, add based on this. And it's tempting to just keep on carrying on, right? Parse HTML. But then you'll notice, well, the names had these little eyes on the outside. The actual flower types don't have anything. So if we were to select maybe body might be something we're inclined to do, then you have the whole thing and you're like, oh, well, maybe it's the first thing in body. No, the whole thing's the first thing in body. You kind of back yourself into a corner sometimes. So occasionally, especially if you're dealing with smaller chunks, it's easier to think of this instead of HTML as just a weird paragraph of text that has a useful separator in it. Sometimes it's easier to frame it that way. So if we don't parse it as HTML and get rid of the TD and the TRs, you can see that the flower names are separated by this TD. So we can just pretend this isn't HTML at all and use this split function, which will work on any string that you want to split. You'll see that now we've got an array and it's separated into things with the TD being the splitter, and that's not showing up. So it uses that to separate stuff, which maybe if we see what all the different array items is useful. So this is the first thing in the array, not useful. This is the second thing in our list. This looks like it could be useful, right? Because this is all the flower names. We may have to deal with this later, right? That's something to know. But generally, this is something I think we can work with, right? So that's news to know. And then you can check out, this is number 2, which is the temperance. And then 3 gives you an error because there aren't 4 items in this index. So if we go to 1, now how do we get rid of that little TD? There are a few different ways we could do it. The first one is to treat it just as a string and use this little tool called replace. And this will do a lot of things. It replaces things. So we can choose this little thing and replace it with nothing. We could also replace it with hello, which is not useful, but I'd like you to know that you can do that. So replace is a good way to find all the instances of a string, whatever you put in here, and replace it with something, including replacing it with nothing. You have to be a little careful with that though, because obviously in this situation, this isn't going to be the part of a flower name, at least not any flower name that I know of. So we can replace it kind of without worrying. But sometimes I've gotten myself into hot water by replacing things because I didn't think it'd show up in the text that I wanted, and then I found out later it did. This happens a lot with punctuation too, but use replace a little carefully. Another option is to parse this as HTML, right? And then it puts it in this little thing. And remember, we can grab the text of any HTML we have. So we can do HTML text. And that also works. So either of those, and I'm sure there are plenty of other ways to do it as well. That's kind of the fun part about this, is there are a lot of different ways to put together an equation, a long expression, and they can get you to the same place. So there's no one right way to do things. So we have flower names here. All right, and then we have flower names. Let's take a look with Facet. And we have 713 choices. All right, so let's take a look. I always like to check the blanks. So there are 60 blanks here, which is promising because if we look at the flower meanings, we'll facet this as well. we'll see that only blanks are options. So that's nice. So if you facet one, limit to the blanks, and then check the other, and it's also only blanks, that means all of our blanks match up. We don't have any errant blanks, and it's all the stuff that don't have flower names and meanings, which is kind of nice. So now we're going to remove these blanks because we're not interested in them at the moment. And easy way to delete is the star, and then remove matching. Now we've got no blanks. We can get rid of this column because we've used it. Same with this one. Just delete. And then finally this one. And then we have a nice little list of flowers and what they mean. And you can also, and we won't spend too much time on this just because we talked about it in the last workshop, but you can cluster, you can work with it. You can see like where there may be potential to work with this data some more, replace things with what you want to replace them, right? So there's potential to work more with this, but for now we will leave it to be. Now we have a nice little 2-column data set from all of this HTML. And we can export to whatever you're so inclined. I'm a CSV lady myself, and you're all set to do with that what you will. Now I'm going to move on to the API and parsing JSON portion of this workshop. So we're going to be going here to the Library of Congress API. APIs are a way to get data quick, to make requests of a set of data held on the web in a really quick way. And there's way better explanations of it. But what you need to know is it's a great way to get information really quick and in batches. And there are lots of APIs out there. Library of Congress is a good one to practice with because you don't need an API key or any type of authentication. You're ready to go. And does the Library of Congress, that's kind of fun. But NYPL has one. NASA has one, which is really nice. You can get space images. And this is a really great time to say URL stands for Unique Resource Locator, and the API is a good demonstration of what that actually means. And almost all APIs will have instructions associated with them, and I highly recommend reading through them because they all work a little different. They all have different ways to navigate them, but they all are really well explained, or at least most of them are, all the good ones. If you ever feel lost, there's usually documentation on it. And you build your query by kind of building the URL of what you want to search. So I'm going to, just for a moment, hide OpenRefine and build a query based on the rules. So here we have the biggest rule. It has to have this in it, whatever your URL is, right? So it has to have https://www.loc.gov, right? And you also have to include FO equals JSON at the end if you want to get JSON as your format. And here it tells you how to build your searches. So anytime you want to search, you have to have a question mark and then whatever your query is. You can also limit to collections and formats, and it tells you where those things should go before or after the question mark. And then it has common parameters or ways to search. These always go after the question mark. So you can search by keyword, or you can filter by location or subject, things like that. You can also limit the results, and you'll see an example of that. But for now, let's try to build a query. So let's say we only want photos. So I'll make this big. This is where we're building it. And then we want to facet it off of the contributor, which is one of the options. And then we can put in the name. And this is one I have prepared, but if this doesn't get any results, you will know. And then we want to add, so we have a little ampersand, a search term. There we go. Let's see if this works for us. And there we go. So that's how I check to make sure I'm building right. You'll notice that this isn't JSON. It's just a URL. That's because we did not add the little JSON indicator. So if we add that, we get the same thing, but this time it's all in JSON. And that's what we're going to be working with. But that's how you kind of work with an API. You build up a search URL. And where OpenRefine comes in and makes this really fun is you can build a lot of URLs at once. So if you have a lot of things to search, You have a lot of keywords, you have a lot of facets or something like that. OpenRefine lets you build a lot of URLs really quickly. And I will demonstrate that. So we're going to go back to OpenRefine. And this time we're going to be working from the clipboard again. And this is a great way if you want to if you have a list of things, the clipboard is a great way to just get a single column list. We will be working with Massachusetts. I'm bad at spelling. There we go. Maine and Connecticut, because those are the states I'm interested in. And this list could be hundreds of items long. I'm keeping it really short just to not bother Library of Congress too much, although I'm sure they get bothered way worse than us. And also just for processing time, because this is something that can take a long time because it has to query the API for each thing. So we're keeping it short. And we're going to next. This looks right. This is what we want. It automatically, figures out what we're doing. We'll give this a better name than clipboard. The last project wasn't so lucky, but this one is. We'll create project. Then we have our nice little search terms. And what we want to do now is build our API query URLs just like we did before, right? So in here, but this time we're doing it in OpenRefine. So we will edit column, add column based on this column. So we will, value means the value of the cell, and it's a variable. You can also have just straight up strings, right? So now this would change all of these to just that one string, which is not what we want right now, but it's good to know. And then we can go ahead and build. So we're going to add photos to the end of this, right? Just like we did before. And then we're going to add our question mark, and we want a facet to be contributor. And if this is like a lot, remember, you can always go back to the API and see how they suggest you build stuff. And so again, like I practiced because I wanted to do a good job for you guys, but you should know I worked with this and built the query, and it took not a huge amount of time, but faster than not as fast as I'm doing it now. So it looks like I'm doing it fast. It's only because I practice. So I don't want to make it seem like this should be easy peasy, but it shouldn't be hard, but it's not as quick as this all the time. So we have the contributor, and then we have our query. And this is where OpenRefine gets fun. So we have this string, and now we can add the value. And now we're querying this, but with a different search term state each time. And again, this is where OpenRefine really gets useful when it is at a big scale. And then we can also add in, I'm going to add in right here. So I will separate this just so it's not too confusing. And you don't have to do this, this is just to make it more readable. So I'm going to add in something that's SP equals 1. And this is limiting the results to just one page. And then I'm also going to add in C equals 3. And this limits the results per page to 3. And this is just being done to make sure it doesn't take forever. I might even limit it to 2. And then we have the value, right? And then we need to add in the JSON format request. And it has a little preview here, which is nice. So you can go check. All right, it works. It's always nerve-wracking in front of a crowd, but we have it, it works, it makes sense. We can click OK. We will do URLs. All right, we have the URLs, pretty quick. And now we can do just like we did with the HTML, we can add a column by fetching URLs. We can make this fetch. All right, and this is the part where it may take a long time. I'd like to remind you that it's connecting to the API, and it's having to do that for each query. So it's like 3 things at once, and Library of Congress can be a little slow. So don't be too worried if this takes a long time. It doesn't mean you did anything wrong. It just means the API you're using can be a little slow. While we wait for this to go, I'm going to show you a really useful tool that we will be using later. It is the Jsonformatter.org. And this is the JSON pretty print tool. I don't know about you guys, but JSON, even in the pretty form, is kind of hard for me to read. And when you get this long string of text, I have no idea what's going on. Some people are really good at it. I'm not one, so this tool has saved me many times. You can just paste in your JSON and make pretty, and this is linked at the end of my slides, so you don't have to remember it. And then it at least adds the indents and at least gives you a sense of the structure of the JSON you're working with. So that's a useful tool, I like to point out. So we have the JSON here, and now we'd like to actually get data from it. So similar to HTML, OpenRefine does have a parse JSON tool. And it's just parse JSON, pretty simple. And you may think, oh, we can just do just like we did before, you know. Select. We're going to be trying to get the results right here because this stuff outside of it, not super interesting. The actual results are what's good about this data. So maybe we can do this. And no, because that's only for XML and HTML. And that's where it's like, why didn't you make them all work the same? Just because they're different formats, and that's how the language works. And it's one of those things where it's like, you're not expected to memorize it. I look these up all the time. So instead, how the parsing JSON works is you can kind of see there are little arrays and dictionaries and nested data in JSON. I mean, that's what it was made for. So instead, we're going to use something that looks kind of like how an array would look like. And we're going to request the results. And you'll see here, this is still an array. So we're going to use, and it's all joined together, the two different results. So we're going to use the same trick we used before, the join and then separate trick, to make sure that these results are separate. I love this trick, especially if you have one cell with a bunch of stuff that needs to be different cells. This is my go-to. So we're going to use that. Once again, I'm kind of a one-trick pony. Hopefully you didn't notice, but we're going to go here, and then we're going to edit cells, split multi-valued cells by the separator. And there we go. So here's a little sanity check. We had 3 different search terms, and we asked for true results from each. We have 6 rows. 3 times 2 is 6. It makes sense. It's all adding up. That's a nice feeling. And now we have little nuggets of JSON that we can mine. We can take all the data out that we are interested in. And this is where it gets really, for me, kind of fun. So we can make pretty, we can see what we're going on. So this is all the information we have access to. We have the contributor, we have dates, we have ID, image URL, and depending on what you're interested in, different areas of this may be interesting. So let's say we want to get the ID for each image. What we can do, edit column. This is the bait. Once you have the JSON in the chunks you like, this is the go-to formula for pulling out new cells. We have value, parse JSON, and then anything you're interested in inside of these quotes, you can get, as long as it's at the top level. And I'll talk about going down a few levels too. But anything that's on this first row, we can get super easy. So ID, forgot those guys. I forget them all the time. So if it's not working, make sure you've written it right. But we have the ID. And now we have IDs for each of the items. Right, so we have all of the things we've got IDs. We can do this for dates as well. Okay. Now I have the dates they were all made, which is kind of nice. So you can really quickly start filling out information based on what you need, right? So we have the dates, and they're all 1941. If you want something that's kind of nested, that's where understanding JSON kind of can be a strong suit, and getting familiar with it. It's a really nested kind of, maybe, I think it's a little bit of a tricky data structure. I really like it, but it's a little tricky. And that's why the preview is really good. So let's say we want the call number. That's nested inside of item, right? And that's where this JSON pretty super useful as well. You can kind of see the structure, but we can go back to results, edit column, add based on this column, same basic formula, right? Nothing too different. But first, see if we call just call number. It's going to tell us it doesn't know what we're talking about. We just get a null. If we call item, you can see that call number is inside of it. We have a curly bracket and then call numbers there. That means we can just kind of easy peasy add it together. And then we have the call number. So you can nest within it. So this whole item, you can treat this as its own little JSON chunk and then do what you would with a JSON chunk. And this is where experimenting and just working with it is really the name of the game. For example, if you wanted the link to the creators, this triple nested thing, it can get a little tricky. And it's just about working with the trickiness. So we have value, done. You get really good at typing this little section though. So we have item, right? And then we want the creators. But then you'll see it's this, a little square bracket, then a curly bracket. So if we did link, just plain, it wouldn't know what we're talking about. So anytime you see a square bracket, that's an indicator that there's an array going on. And just trying indexing usually works. So now we have the square bracket, and then we can do link. And this is all just kind of practice and getting used to it. But now we have the creator link. And again, it's when this is scaled up to hundreds of rows and you can get the dates for hundreds of items all at once, easy. That's where it really starts to kind of be magic. So that's JSON. And once we have all the links we want, we can, same as before, export as a CSV. Maybe I will delete this giant JSON row because it's not helpful. We can delete this. And we can delete this just to make it equal number of rows and records. But once we've done that, we can export. We can keep this JSON if we so desire. And then we have a CSV of all this information. Thank you for having me. Bye, everyone.